Hello, everyone. I hope everyone can hear me fine. Today I'm going to talk about the draft I am working on or been working on for health-related performance assessment, a framework for smart ventilation. So this is work I'm not doing alone. A lot of the work I'm going to present today, has been a teamwork together with Janneke Gijsels. So a shout out to her. I'll right from the bat want to start thanking Ghent University and FWO for funding this research and to give me the opportunity to dive into this. So ventilation, if you look into what it influences, I think there are five main things. So there's comfort, there's health, there's heating energy use, cooling energy use, depending on the climate, of course, and then the fan energy, or we could do it a bit broader as the operational energy use. If you look into the Belgium context today and look at performance assessment of systems or smart ventilation systems, it looks kind of like this. So our current framework includes a simulation setup where we have a building or a set of buildings. Actually, we have pollutants, we have people that live in that building. They shower, they clean, they cook, they breathe, and they go to the toilets. And all of that produces pollutants. And pollutants that are included in the simulation at this point are CO2, H2O, and a toilet. So it's basically a tracer that can simulate or can simulate the smell if you go to the toilet, because you don't want that smell to go into your building. The goal of my research is to expand that method, so which had only comfort parameters in there, with health pollutants. So this, of course, defines a number of challenges. First, you have different kind of sources. So you have people and their activities, you have the building itself, but also furniture, and then you have, of course, also the outdoor pollutants, like Evangelos also said today. These challenges I summarized for this presentation in two main big questions. So first is, how do you assess such a system? How do you score health? How do you check the performance afterwards? But then also, of course, which pollutants are the important ones and which sources should be taken into account. To answer the first question, we first took a step back and said, okay, how can you, or what should this assessment method, this framework, how will it be used? And there are basically two things you can summarize it in. The first one is, okay, you want to have sort of a tool in the design phase in the development of new goal strategies to predict what the performance would be before you start installing it in all of your residential buildings. So that's typically done in simulations, but on the other hand, you also need a tool to go into a building, measure, and see what is the performance. So this framework should be able to cover both. So you want this metric that can be used for both measurement campaigns, but also for simulations. Now, the problem is that we found when trying to come up with the right metrics is that the kind of data you get from simulations and from measurements is different. Typically, simulations, you have a very high resolution. You know where the people are, you know what they are doing at which points, you know what the concentrations of each room separately is. But on the other hand, of course, it's simulation, so there are a lot of assumptions. So if you don't implement it, you're not going to find a certain pollutant. On the other hand, measurements typically, and then I'm looking into passive sampling because that's the measurement mostly done there, with a very low resolution. It's a weekly average, daily average, maybe if you're lucky. But then you get actual values and you have a better, broader perspective of what's in the building. Now, to handle this problem of resolution and how it fits to a metric, we define some key principles we think performance assessment should have. First one is it should be occupant-centric, which means that it shouldn't be based on the room concentrations, but should be based on exposure concentrations. This is just if you want to give smart ventilation a fair chance and you're looking at health, it doesn't really matter that the concentration in your building is high if you're not there to breathe that unhealthy air. So basically, you need to look into what is the occupant doing, where he is, and then you can start optimizing your airflows. The other second key principle is a double check, I called it. It's basically splitting up the minimum performances and then the relative performance, because we believe that first of all there should be some absolute limits to what is fine. So you need a kind of boundary, a playing field that's quite well defined, and within those boundaries you can start optimizing and seeing what are the optimum. So the pass or fail is basically your minimal performance. If you pass the first absolute limit test, so you're inside the right playing field, then you can go on to scoring, which means you can go look into relative performances, energy use, energy savings, but also then disability adjusted life years, but more on that later. And then again, as a third one, as I mentioned, it should be applicable to different data resolutions. So I mentioned passive sampling, but also other kinds of measurements could have a much higher resolution. And then it's also always a shame to say, well, I have this high resolution and now I take the average and then I check against a certain limit, which is kind of strange because you have the more detailed info, but you're not really using it because you're averaging it out to check against a certain metric. Then to the big second question is which pollutants, which sources do you include in this kind of framework? And this is based on our experience, let's say. So based on what we've done and some side roads we took first, I distilled what was the final method or what could be a proposed method for maybe other countries or researchers to go ahead and try to implement. In basically 3 steps, quite obvious, I guess. You start with measurements because you need to know what's in your buildings, what's out there. You need to know which pollutants you can find in the typical buildings of your country, because building methods are different. Legislation about what kind of VOCs or pollutants can be in certain furniture can be different. So there is possibly a big difference. Based on the measurement, you need to identify the pollutants of interest. So you're going to find a whole bunch, of course, but you need to filter out which ones are important. And we basically did it in 3 levels. So you looked at what occurred a lot, what are the concentration levels, but also what is the health impact at that concentration level. So you could find a pollutant with a very high concentration, but if it's not harmful in any way at that concentration, it doesn't really make sense to put in all the effort of modeling it and implementing it, or even analyzing it for the purpose of assessing. And then, of course, once you know the pollutants, you need to identify the sources. I really think this is a very important step because those measurement campaigns or measurements that were done should be able to give feedback to the sources or the manufacturers of those sources. So imagine that we find high formaldehyde concentrations, and it's still that's the case in 10 years. And we are pressuring the building construction and flooring manufacturer as well. You need to implement less formaldehyde. But what we didn't notice was that actually there is a new source, maybe quantum computers or something emit formaldehyde, and we're missing out on that complete source, and we're pushing in or informing at least the wrong people of well, the harmful VOCs they are emitting. So going through that process, so if you looked at the first measurements, you identified the pollutants, you know the sources, you can do 2 things with it. So you can add it to a simulation framework, and based on that design, make your design simulation framework. And on the other hand, look into evaluating pollutants for scoring when you have measured the VOCs. Important point there is that if you do measurements, typically, again, you'll find the pollutants you're interested in that are part of the framework, but you'll also find the other pollutants. I think it's a very important step that we need to think about is if we have those measurements, we'll find other pollutants, also analyze those and see, okay, do we notice that some pollutants start emerging more and more, or maybe concentration levels rise, and maybe there should be this feedback of those measurements back into the framework, and then in the end, if agreed upon, go in the simulation framework and in other. So this is more of a general. So like I said, we're in the process of doing this for Belgium, let's say, so case Belgium, but it's still a draft. Like I said, so I'm going to show you some metrics, but we're still investigating if they are indeed applicable, if it makes sense to, if all the choices we've made actually make sense. So to start, the minimum performance metrics, so the checklist to pass or fail. We have two categories. The first one is based on the exposure concentration. So this is a fictive example. So if you look at exposure concentration, the first check we're going to do the AEGL, which is basically really for acute effects, which means that if the exposure is at this concentration, you'll have an acute effect, or maybe your eyes start watering, or you have dry mouth, or really you just start to feel it. And we don't think that in a residential context, at least, you should have any acute effects at all. But that's only for very, very peak. So you don't really have the duration factor in there. So to get to different kind of resolutions, we'll need to look into other checks, let's say. So based on exposure concentration, we, for instance, look also at the 1 hour moving average to see, okay, what was the average exposure of the last hour, and check that against REL, which is indicated or calculated for a 1 hour exposure. Then we do the same kind of exercise, an 8 hour interval, and then at the end, and those are the ones that are typically used, are the chronic. So then we have the really average ones, but still nonetheless important. The other minimal performance metric we propose is the LADD, so the lifetime average daily dose. Why? Because it's very closely linked to metrics used in epidemiological research, the hazard coefficient and the lifetime cancer risk. And also, and that's specifically for Belgium, in our existing framework, we simulate adults, but also children and even a baby, which means that we have information about different different family members doing different things, having different kind of schedules. So we wanted to have a metric that also includes the information we already have and takes that into account in some way. And what the LADD does, it takes into account age and body weight to go from intake to the LADD. And that one we can check against the hazard coefficient and the lifetime cancer risk to just see if it goes above a certain limit or not. For the relative performance metric in Belgium, we propose the DALI for a couple of reasons. But first of all, or the main reason is it's summable. So because it's a metric of harm, which means it's not just is it over or not, if you really get a number of, okay, this is the harm this concentration or this exposure does to a person, makes it summable, which means that if you have different pollutants, you can calculate DALI for each of them, add them up more or less, and get one score of your building, which is well, practically good if you want to really score it and compare with other results. We based our calculations on Logue et al. So we both use it, for the more experts, we use the IDN, the IND method. but we needed to reformulate it a little bit to, well, again, match the smaller resolution you have in simulation frameworks. So we have our pass or fail limits, we have our relative performance metric, and then we went further down this tree, but we only took the left branch, so we only looked at design simulation framework because that's where my research is, but so we're not currently looking into the measurement part of it.
5 minutes.
Yeah, no problem. So what we did is we looked at the concentration levels indoor, and based on that, like I said, we applied a filter. So we looked at, okay, which are the target pollutants we find in there. Based on that, we went to look into databases and in research to look, okay, what are typical sources of this, and try to add this out. So there are much more arrows than are on this slide, which is just to indicate how we implemented it in the simulation software. And as an example, I just simulated a reference system, so continuously ventilated, and a smart ventilation system. And I'll show you all the results for a formaldehyde exposure concentration specifically. So this is a result, just I zoomed in on a week. You can clearly see, so it's the same person, the same house, the same boundary conditions. The only thing that changes is the ventilation system controls. So you can clearly see that the smart ventilation system, the exposures go up. You then look into the LADD, so it's that the more integrated results, and check it against the hazard coefficient and the LCR. It actually fails, so for the lifetime cancer risks, it fails at this point, but also the reference systems fail, which we didn't expect, but so we're looking into how to handle this, or is it something wrong in the assessment, or is just every concentration level, basically, or all the houses now in Belgium a lifetime cancer risk if it concerns formaldehyde, which is, well, we hope not, but still. Then the relative metrics, so we have the DALIs. So you can clearly see that during the simulations, the DALIs accumulate, and because of the higher exposures we got for 100,000 people, we accumulated to 4.6 years disability just at life years lost, which is hard to say if that's okay or not. It seems it's more of an ethical question than a mathematical one, so I'm going to leave it there. And then, of course, in the end, if you know your DALIs, you can start looking into, okay, I have 4.6 DALIs I gained, but I also gained well, energy use. Voilà, so this was my presentation. So I was Klaas De Jonge. If you want to contact me, go ahead. And I'm also going to introduce the next speaker, which is Leon Walker. He's going to talk about the application of smart ventilation systems